Welcome students. Welcome to my new channel. Study of. Yesterday I have discussed about the word. Today I will discuss what I done. That is the energy. Okay. What is energy? How and what is the utility and how it is used. So that's what I discussed in my video. So let's start. So today I will start energy. So before energy, one thing is I have to discuss about work. When work is done against gravity, at that time what will be used as a formula? W equals to Fs. Not against gravity. Suppose you are doing a work against gravity. In that case, W work done equals to weight of the body into the product of the weight of the body and the height it is lifted. That is the work done. It will be calculated. That is what means M into G. W equals to mg weight into height. W equals to m into g into height. Clear? What is m? M equals to mass of body, G acceleration due to gravity, and h is the height of the body is lifted. So in that case, the work done will be calculated by applying this formula. W equals to mgh. M mass of the body, acceleration due to gravity G, and h is the height is lifted. Okay. So next energy. Okay. What is energy? What is energy and how it is related to work? What is energy and how it is related to work? How it is related to work? What is energy and how it is related to work? Okay? Life is impossible without energy. We use energy to do work. All I know. We use energy to do work. Suppose cars, machines, planes, so many things what we in our day-to-day life, etc. transform energy into work. We often said, for example, a Tannu, a boy, a lady, girl, a Tannu is more energetic than Mannu. What does it mean? Tannu is more energetic than Mannu. What does it mean? That means Tannu can do more work. Clear? More work than Mannu. This is the thing. While doing work, we expend something. While we're doing some work, we expend something and gets tired. Something क्या है? वो है energy. कई जो बॉडी है, एनी बॉडी जो ऑब्जेक्ट जो है वो इनएनिमेट हो और एनिमेट हो, वो मशीन हो और कोई पर्सन हो, जो कोई वर्क परफॉर्म करेगा, या इट इज सेड टू पोजेस एनर्जी. जो काम करेगा उसको एनर्जी पोजेस करना होगा. कोई वर्क परफॉर्म करेगा, you possess energy. So thus, what is energy? Definition of energy. Energy is that anything which is capable of doing anything, or capacity of doing anything, capacity doing work by a body is known as energy of the body. Again, I am telling anything which is capable of doing anything, clear, or capacity of doing work by a body is known as energy of the body. Clear? Energy हो गया, या है ना? What is the unit of energy? यूनिट, जो यूनिट हमने बोला वर्क के लिए, वो We have energy का unit because energy is the form of work. To do work unit work का जो unit है, energy जो unit है same है. Now I am coming the last part. Last no, the various forms of energy. What are the forms of energy? There are different forms of energy. Energy can be transformed in one energy to another energy. Conservation of energy will come later. The various forms of energy क्या है? The mechanical energy है, या का solar energy है, heat energy है, thermal energy है, sound energy है, light energy है, biomass energy है. So many energy are there. Okay, so many energy are there. The mechanical energy. What is mechanical energy? It is the sum of the kinetic energy and potential energy. What is kinetic energy? I'll discuss. What is potential energy? I'll discuss. The mechanical energy is the sum of kinetic energy and potential energy. Not solar energy. Energy radiated by the sun. We know. Heat energy, thermal energy. What is key? It is all the energy released by the coal and oil. From the coal, burning of oil, whatever energy we gain, that is the thermal energy, heat energy. Okay, so there are various forms of energy are there. That is light energy, wind energy, sound energy. Sound is a form of energy. Light is the form of energy. The sensation to our eye and this is an ear in case of sound. So sound energy, biomass energy. So all are energies there and go through the book. Although I do not require to just discussing this out here. Now I am discussing the most important part of this kinetic energy. What is kinetic energy? Kinetic energy क्या है? What is kinetic energy? Kinetic energy. See out here that kinetic energy, moving object is capable of doing work. Clear? Moving object is capable of doing work. How? Suppose I picked a ball and kept in the table. Okay. I kick a football. Anything? The moving object is capable of doing work because of its motion. The Greek word kinetikos. Kinetikos इसका मीन क्या है? Move, to move. The Greek word kinetikos means to move. Okay, that is motion. So when a moving object, say a ball, it is moving object, is moving. It is moving object. When a moving object, say ball, hits another object, that is stationary object. The moving objects, ball suppose, hits another object, a block, wooden block. Suppose a moving object, say ball, hits another stationary object, say wooden block. What will happen? That means this wooden block is displaced from its position. The wooden block is displaced from its position. It will tilt it. It will move. It will displace the positions. Suppose what you see out here in the cram board. Again, I am giving the examples. ऐसे हम हिट कर रहे हैं स्ट्राइक के लिए एक गुटी को हिट कर रहा है. And this is the moving object is the striker and it hits the another object and it will move, it will displace. So what we see out here, the moving objects hits another stationary objects, it displaces from its positions. That means this stationary object displaces from its position. The moving object has kinetic energy. Moving object has kinetic energy. Yeah, that is known as kinetic energy. Has energy. This energy known as kinetic energy. That moving object has energy. This energy known as kinetic energy. So what is the definition of kinetic energy? Let's see. Tell me. Anybody? You? Oh, okay. Little difference. Okay. So let's see. I am telling the energy possessed by a body. Energy possessed by a body. This body, by virtue of its own, by virtue of its motion. The energy possessed by a body by virtue of its motion is known as kinetic energy. Are you watching? Are you watching? Clear? The energy possessed by a body by virtue, okay, of its motion is known as kinetic energy. An example. So many examples are there. A moving ball. A moving ball, this is example. A moving train. A moving bus. A rotating motion. A bullet fired from the gun. Bullets. If I fire the gun with the bullets, what will do? It hits the earth and you will be out. So many things. Okay, I am throwing a stone. All moving objects, all moving bus, trains, planes, all are kinetic possesses energy. It is the kinetic energy. Clear? So, expressions of kinetic energy. How to express kinetic energy? Now, how to express of kinetic energy? The expressions of kinetic energy. Expressions of kinetic energy. Expression of kinetic energy. So, bachcho, note it down. It's very important. What is the expressions of kinetic energy? Expressions of potential energy. All you have to know. The derivation. Suppose an object. This is the object whose mass is m. Okay? The mass is m and the initial velocity of the object is u. That is at rest, it is 0. U equals to 0 at rest. When a constant force F is applied, so the force is applied, it will move. So then final constant external force is F and the velocity from U after some time it will be V, and the acceleration during this displacement S, acceleration be A, the initial velocity U, the constant external force F, acceleration equals to A, and final velocity equals to V, and displacement out there S. From here to here displacement is S. So from this point of view, how to derive the expressions of kinetic energy. See, so out here, jot it down, okay? लोड शेडिंग हो गया, करंट नहीं है, कैसे पढ़ाओ? So थोड़ी वेट करना पड़ेगा. So वेट करो, I'm coming.
From v square minus u square equals to twice as, the rest will be find out. And v square minus u square twice as, this equals to v square minus u square by 2a. What we know from the Newton's second law, F equals to ma. And what is w equals to a rest.
So from the equation of motion, v square equals to u square. V square minus u square equals to twice as. We know. So from these equations, what we do, we get twice as, s equals to v square minus u square by 2a. 1. Okay. Is it clear it? And from the Newton's second law, what do we know? F equals to ma. F equals to ma. Newton's law 2. And so work done by the ball. What is the figure out there? What you see? The U, then it is V. It is U, constant force F, S is the displacement. So work done, W equals to F into S. F into S, clear? W equal to F into S. उसके बाद क्या होगा? See, F equals to ma, that is ma into S equals to this. You have to put the value F equals to ma and S equals to this, v square minus u square by twice a. This a cut दिया. Okay, that means ये क्या होगा, mv square by 2, mv square, that means half mv square minus half m u square. Clear? Half mv square minus half m u square. Clear? So this is the work done. This is the work done, half mv square minus half m u square, half m v square minus half m u square. Sorry, it is u square and u equals to 0. So this part will be 0. So work done equals to half m v square. This is 0. So equals to half m v square. Okay. This is the work done. Clear? So now from this, what we observe out there, W equals to half m v square. Half m v square as u equals to 0 out here. So in this case, a W equals to what? Half m v square and u equals to 0. So in this, W out here, W means what? W means what? That is in kinetic energy. So kinetic energy equals to half m v square. Half m v square. Okay. So this is in form. You can write, jot it down. Okay. Say W means Ke, kinetic energy. Ke. W equals to out here energy equals to half into mass into final velocity, that's square velocity square, final velocity obviously, half m v square. This is the kinetic energy equals to half m v square. This is the relation, and by this relation, by equation, so many problems will come, so you have to solve by having this, applying this formula. Okay, next. Very important. Kinetic energy equals to half into mass into velocity. Next. So, what energy theorem? From this kinetic energy of work which will happen v square, what do we get? It is the work energy theorem. Very important. Work energy theorem. Work energy theorem. So work energy theory, what we just come to know, W equals to, that is kinetic energy. W equals to what we got, half m v square minus half m u square. You got it? Okay. So W equals to half m v square, half m square. It is known as the work energy theorem. Work energy theorem. That is the final kinetic energy minus initial kinetic energy. Then W equals to final kinetic energy minus initial kinetic energy. Final kinetic energy minus initial kinetic energy. Okay, that is, we can write it change in kinetic energy of R. Yeah, change in kinetic energy of a body. Clear? Of a body. W equals to half m v square, final kinetic energy, initial kinetic energy. There is change in kinetic energy of a body. Okay. So, change. What is the theorem? The theorem work done. The theorem. Suppose the question is state the work energy theorem. See, so you must tell the work done, W, by a force on a body, work done by a force applied on a body is equal to the change in kinetic energy. Work done by, okay, clear? So this is the theorem. Now from this theorem, what we know, EK, kinetic energy equals to half mv square. We know, clear? So, okay, so EK varies what? M, that is more the mass, more the kinetic energy, more the mass, more the kinetic energy, and EK, kinetic energy, varies as v square. Okay, so if you double the velocity, the 4 times will be the kinetic energy. Clear? So it is very important. A loaded truck, kinetic energy is most, velocity double हो गया, so kinetic energy 4 times हो जाएगा. Clear? So it is very important. Note it down. Suppose a sums, only one sums. If suppose how fast would a man go of 60 kg run so that kinetic energy is 750 joule? How often would a man of 60 kg run so that his kinetic energy is 750 joule first? So how far? That is the velocity. Okay, so you have to find out EK. EK equal to half mv square. You have to find out. So you have to find out the velocity. Velocity is root over this into this, and most probably the answer will be 5 meters per second. Okay, so do it at home. Goodbye. So don't forget to subscribe. Clear? I am with you. You are with me. So like it, share it, and I will also share all my views to all of you. Thank you. Bye.